consider that for something like a paraboloid, this guy does have local max. It does have an absolute max, but it has no absolute minimum because we're assuming that the graph continues indefinitely downwards. Now, there is a nice theorem that gives us some guarantees about when we will have, for sure, an absolute max and an absolute minimum called the extreme value theorem. To develop that theorem, let's consider some of the topics that we have to discuss. One of the topics is the concept of bounded. A set in 2 dimensions R2 is said to be bounded if the points do not go off indefinitely in any direction. This is a rather informal definition, but it gives you the main idea of what it means for a set to be bounded. So consider in 2 dimensions x and y, R2, are set to be this set right here, this collection of x's and y's. So our x's and y's don't go off indefinitely in any direction, right? They're within this scope where I can see them all. If I zoom out far enough, I can see them all right in front of me. So this is a bounded set. For comparison, let's consider an unbounded set. Let's say that the x's and y's you're considering are all the x's and y's with a y value between, let's say, 1 and 3. So you're considering all of these points here, including all the points that go off indefinitely in that direction and indefinitely in that direction. No matter how far I zoom out, I will not be able to see all of the points all at once. So this is a set that's not bounded. We also need to talk about the concept of a closed set. A set in R2 is said to be closed if it contains all of its boundary points. So again, in 2 dimensions, the xy plane. Let me give you this set right here. The x's and y's, all in green, are part of my set. And in particular, the boundary of this set is the edges of this circle. And those edges for this particular set are included in my set. So in this case, this would be a closed set. By comparison, consider this set, which looks very similar. Except I'm omitting the boundary. So because you don't have these points on the edge here as part of our set, we don't have closure, so it's not closed. And from these two concepts, we can talk about the extreme value theorem. So let f of x, y be a continuous function on a closed and bounded set D. So this guy is closed and bounded. So bounded means, again, that it doesn't go off indefinitely in any direction. And closed, it means that it has all of its boundary points. Then this theorem guarantees that this function will attain its absolute maximum and absolute minimum values. Okay, so again, if you have a function that is continuous, then on a closed and bounded set, then you're guaranteed to have both an absolute maximum and an absolute minimum.